This is our video for Thursday, April 24th for pre-cal. Our objective today is to be able to write equations of conic sections given graphs or information about it. You're going to need your books open to page 646. Just to review, Monday we talked about circles, Tuesday ellipses, Wednesday hyperbolas, today writing equations. All the homework is due by midnight tonight. And tomorrow we'll have a little ACT style quiz, and it will be on Schoology and it will be multiple choice. But do go ahead and show your work on a piece of paper and email me that so that if you miss the multiple choice part of it, I can give you partial credit like I normally do. So do the quiz on Schoology, submit it, but then email me your work that you did on paper. All right, so when I was looking through the different ACT practices and tests, a lot of what they wanted you to be able to do was to look at a graph and write an equation, or at least understand how things were graphed and coming up with an equation. So on page 646, on 1 through 6, they have matching. And so they have 6 ellipses graphed there, and then they have 6 equations, and they want you to match them up. So let's look at number 1. It is x squared over 4 plus y squared over 9 equals 1. And number 2 is x squared over 9 plus y squared over 4 equals 1. Now we know that this section is ellipses, so we know that we're looking for an ellipse. If this were an ACT, the giveaway that it's an ellipse is that it is a plus sign. If it were a minus, it would be the hyperbola. All right, so these two look very similar. The only difference is that the 4 and the 9 have traded places. So remember that with an ellipse, a is the square root of the largest denominator. And so in both cases, the a is going to be the 3, and the b is going to be the 2. In both cases, the center is 0, 0. So the only difference between these two equations is that for this one, the 9 is underneath the y, and for number 2, the 9 is underneath the x. So if the larger denominator is underneath the y, that means that this is a vertical ellipse, which means it opens taller, or it is taller than it is wide. And here the 9 is underneath the x, so that makes it a horizontal ellipse. So when you look at your choices, your A, B, C, D, E, and F, we're looking for the ellipses that have a center at 0, 0. And so we have C, B, D, and F all have a center of 0, 0. And we're looking for ones that have a major axis of 3 and a minor of 2. So C has a major of 3 and a minor of 2, and so does B. B is vertical and C is horizontal. So the vertical is going to be the B, and the horizontal is going to be the C. And that's the kind of thing that you would need to be able to do on the ACT, because they would have these two options, and they would have one of those graphs, and you would have to figure out which is which. And so if the larger denominator is underneath the y, then it's going to be taller, it's going to be vertical. If the larger denominator is underneath the x, then it's going to be a horizontal version. All right, number 31 on page 647, it says find the standard form of the equation. So they're giving you a graph, and they're wanting you to write the equation. So to be able to write the equation, we need to know what the center is, we need to know A, and we need to know B. All right, I want to do the easy part. We know it's going to be equal to 1. All right, so when you look at your graph of your picture, you can see that the center is between these 2 points. We've got 1, 3 and 3, 3. So right in the middle is 2, 3. So the center is going to be 2, 3. So again, I'm going to go ahead and do the easy parts. So that's going to be x minus 2 and y minus 3 squared. Okay. All right. Now, this is a vertical. So the center's right here at 2, 3. And it went all the way up to 2, 6. So from 2, 3 to 2, 6, that's 3. And from 2, 3 to 3, 3, that's 1. So our A is going to be 3. And our B is going to be 1. And again, it's vertical. So a squared is going to be underneath the y. So the 9 will be underneath the y. And 1 squared is 1. And so x minus 2 in parentheses squared over 1 plus y minus 3 in parentheses squared over 9 should be the equation of the graph of the ellipse in number 31. Now, I've also put in a few hyperbola matching. I didn't include circles because we did that on Monday when we talked about graphing circles. But in my research, I have found writing equations for ellipses, hyperbolas, and circles. So your work for today will be in 2 spots. On page 646, I want you to do 3 through 6, 32, 33, and 37. And on page 656, 1 through 4. And we'll make sure you get that turned in by midnight tonight, and our quiz tomorrow will be in Schoology, and remember to send me your pictures.